Alright, I've broken this up into two videos. So here we are in the second half of it. And I guess we're in, what about section 7 of the on-ramp. So on this one, they wanted us to go look at random integer at the documentation. We looked at the documentation. So create a matrix named X, and I've got a matrix named X that I've created. I use that random integer function. I go from 1 to 20. 1's the default value. If I wanted it less than 1 or higher than 1, I'd be explicit about it. But it's an implicit 1 by not putting it in there. Comma, 5 rows, 7 columns. It ran it. And come back that we're good with it. And then we'll move on. Once it gets through what it's doing, we'll move on to the next section. So we're going to start plotting these vectors that we've been manipulating. So it's pretty straightforward. We're just going to use a plot function. And we'll pass it what it is that we want plotted. Now they go in the order of X and then Y. So the X is going to be sample, and the Y is going to be, for this, mass 1. Okay, now if I submit that, it'll run, and it plotted it for us. Now it's basic, but it's still a plot. A lot of times we'll want to add some labels and things like that. We'll deal with that a little bit, but for now, so now we're going to look at, in task 2, we're going to plot again, but we're going to change how it looks, change the appearance of it. So we're going to do, you know what, I'm going to take that code and I'm going to use it again, but instead of mass 1, they said mass 2. And along with that, we're going to modify the line specifications. And I can go click on this line specifications and it'll open up. Here's all the little ins and outs to how the lines are set up. You want to change the line style, the line marker, color name. We'll do that in quotation marks. Any order, it doesn't matter what order they're in. But then we've got tables, the source table, TBL, xvar. These are things that we can go in and change the values of these variables in MATLAB. So for now, let's do our quotes. And they said they want us to do red and asterisk, and that's it. So if we go ahead and run it, it's all it is, the red asterisks. Now, when we go to this next task, they say, all right, we're going to go ahead and put hold on. So in table task 3, we're going to say hold on. Now what that means is I want to stay on this same plot. I don't want to move on to another plot. So I'm going to stay on this same plot. And you see here, they did a plot, hold on, and then a plot. And then that ended up combining those two plots into one plot. One just kind of laid over the top of the other. So what they want us to do is now plot what we had, sample and mass 1. All right. And and they want us to use black squares. So, comma, quotes, K, and then S. When I submit this, it added that to this same plot. It didn't create a new one. So we're saying, hold on, let's add this to it. Now, go to the next task, and they say, go ahead and say hold off, turn off the hold. And now we're going to create a new plot. So go to new task, plot V1. Okay. So here's a vector, plot V1. Go ahead and submit that. And there we go. There's our vector for B1, or V1, plotted. Let's do the same thing, but let's add to it a line width of 3. So we don't have a hold on, so it's going to create a new plot. So here's our original plot of V1. Here's a thick one of V1. And now this next one, we're going to go to task 7, plot V1, and sample. So it's got to be sample first, then V1 because of the X to the Y. Do quotes. We're going to do R, O, dash, doesn't matter the order on those, comma, line width equals 4. Go ahead and run it. And that's what they wanted it to be. So there's a lot of different variations on what we can do. Formatting the lines, formatting the markers, all of it. It's just getting used to the things that we can do on plotting. Remember I said this is geared towards mathematicians. So now we want to annotate the plots. We don't have any legends or labels or titles or anything, so we're going to go ahead and do that here. So let's say title, we're going to pass the title sample mass. If I run that, now we've taken that, we've added to it. What else do we have? Let's go ahead and we'll put a Y label on there. And our Y label that. You know what? They didn't tell us to, but go ahead and say something. I don't know what it is. Let's go ahead and submit it, see if they like what we did. Yeah, you did what we wanted you to do with Y label, and then you added something down below because you could. Okay. Our next task, we're going to have to create a legend. Now this legend is going to have two values. And we're going to say exp A and exp B. Go ahead and submit it. And there we go. Now we've got a legend, labels, title. We laid this out the way we wanted to. So there's different ways to go ahead and set up plots of our vectors. Okay. On to the next, and we'll go to the next section. Pause mine and watch their video. We'll move on to bringing in data as a table. Now, up to this point, we've dealt with data in the forms of arrays. Let me say vectors, matrices, scalars, whatever it may be. For those that have dealt with Python in the past, we can, if we're just using the basics of Python, all we have is a list. We don't have a array. But if we do an import and bring another library in, we do have arrays available if we beef up our Python libraries. We also have in Python a data frame, which works much like this table that we see here. So we can put labels on the columns and rows and access the data in those columns and rows by the label or the name. So with that said, let's go and assign the contents of one column of this table to a column vector named D. So I'm going to say D equals. And all I'm going to do is I'm going to copy this so I don't have a typo. And I had a typo anyway. There we go. So I'm taking elements, which is the object, table object. Density is one of the attributes of that object. So I want density, get what's in there, and store it in D. It's going to go ahead and do it. It does it as a vector. So it's a column vector. We'll go next. It says, all right, let's do some multiplication. So you're going to get this vector that we're going to create. We're going to call it elements mass. And it's going to equal elements density. I need the period and then the asterisk. So it's times elements dot volume 1. I'll go ahead and run it. We've now created this element's mass. Okay. Now, the next that we're going to do is we're going to manipulate this table. And this table that we've got, I could go in and write another line of code in here to sort one of these columns. Sort the whole table by one of these columns. But instead of going that route, what I can do is I can come over here and mouse over mass. Do the drop down and say, you know what, I want smallest to largest. And when I did that, it sorted it for me and it said, hey, here's a line of code that's needed to make that happen. Okay, well, if I click update code, it will modify that section with that line of code to make that happen. So it's generating some code for me. So with that said, we'll go ahead and say, is that all we needed to do? Yeah, that's all we needed to do. You're good. Next task, next section. So, logical indexing, and in logical indexing, we're doing comparisons. And we're going to get a variable x, and we're going to assign a value to x. And this value is going to be a Boolean, true or false. All right. And that true or false is going to be derived from a comparison. So we're going to say pi, and that's what they want us to reference. Come on. There we go. Pi is less than 4. So if pi is less than 4, that's a comparison. It's either true or false. And pi is less than 4, so true will be saved in x. If I run the section and selection, it's logical, it's a 1 or a 0. 1's true, 0's false. So there we go. We're good. It saved that value. So now we can go on to the next. How can we do some additional character or comparisons? Well, I want to compare what's in V1. All right, and I'm saying I'm going to create a variable called y. And y is going to be the comparison of V1, all the elements in V1 that are less than 4. All right. So here's everything in V1. Doing the comparison, are they less than 4? Now, how many of them are less than 4? 2. The zeros are false. All right, I liked what we did. I'm going to carry on. Now, at this point, we're still doing comparisons, and what we're going to do, all right, we're going to create a variable z, and z is going to be equal to v1 such that v1 are less than 4. All right, so I'm going to say the elements of v1 less than 4. Oops. There we go. v1, where v1 is less than 4. Let's go ahead and submit it. It says yeah, so essentially all I'm saying is go get me what is less than 4 and return me those values and store them in Z. Up to this point, we were just storing whether they were true or false. Now I said, hey, the ones that are true, go get me the values. All right, so the next step, we're going to create a variable a that contains the element of sample. A equals sample corresponding to where v1 is less than 4. Okay, v1 less than 4. Let's see if it likes what we did. And it did. So we look in the sample object for any of them that are less than, and there are 2. So for the last task in this section, so it says modify v1. v1 such that v1, any value less than 4 v1 less than 4 equals 0. So I said, go get anything less than 4 and make it 0 in v1. I liked what we did, and 2 of them were replaced. And that'll get us to the next section, and we're dealing with programming constructs. There's a little video for you to watch, and then when you come back, I'll see you in the next slide. So welcome back, and we're here now on the next slide. Okay, at this point, we're going to put conditionals in place. So we want if conditionals. Oh, they left me a little spot here. And I want my conditional if doplot is 1. So if doplot is equivalent to 1, I'm going to tab in, because these things will happen if this condition is true, and then afterwards we're going to end. So if has to have a corresponding end. Doesn't necessarily have to have an else, but it does need an end to that conditional. That's just one of the quirks, one of the things that the way we've got to do it in MATLAB. Okay. And for those that have dealt with other programming languages, more than one programming language, you're familiar with these concepts already. So we go ahead and submit it. And yep, it went and did what we did, conditional to doplot is 1. Okay. So with that done, let's go to task 2. And in task 2, they want us to add in a line. I'm going to say else, and then will copy for me. Let me see. And there, it did go for me. We'll see if it actually runs the way I want it to run. And it liked it. So, remember I said we weren't required to have an else, but they wanted us to go put in an else. If the condition is met, do this. If it's not, do this. Okay. So we were able to do it. We ended it. The next task, we could have nesteds. If, else, end. So nested conditions, we can do that in this. So this, all we're dealing with right now is just the interface and the logic of what takes place in here. So on this, we're going to put a conditional in here. And it's not just an if conditional, it's going to be a repetitious or loop structure with a conditional. And let's set up the loop structure. The conditional is how many times we're going to do whatever it is. And it'll do a test each time it goes through. So say IDX from 1 to 10. So we say from IDX equals 1 to 10. I'm going to tab this in. Tab that in. And then I want to end my for loop. So there it is. The things that were going to happen are happening just like they wanted, but now they only happen IDX is 1 to 10. Happens 10 times. I submit it, and there we go. So that's our repetitious structure, or our loop, and the conditions that have to be met for it to go through that loop and when it ends. So the next, we're dealing with stellar motion. I've got a video that you can watch there. And essentially, we're going to create a variable, lambda end. It's going to have a value for last wavelength in the recorded spectrum. And then you can evaluate the expression. So we're going to use lambda end to create a vector named lambda. Okay. Now, let's go ahead and start this out. So I can say, hey, give me some hints. What is it that you want? So we use different operators to do the expression, build the expression out the way that we want it. Okay, from the start to the end. There's the start, there's the delta. And essentially, here's the code they want from us. Lambda n equals the start plus that size of the spectra 1, etc. It's convoluted and not something I want you to dwell on all too much, because we can go in, check the solution to get through it. It says, yeah, we did what we had to do. All right. So let's look at this next one. We're going to extract the 6th column from spectra, and we're going to put it in a vector named S. Okay. Okay, so now we're going to take this and let's go ahead and, well, we're going to do colon, comma, 6. And that should, let's see how we turned out. It liked it. So we've got 2 out of the way. Let's go to the next one. And we're going to deal with this calculation. They want us to plot S as a function of wavelength, lambda. Okay. So let's say plot, and we're going to say wavelength and intensity, and let's see if it'll let us go with no quotes. Maybe it'll recognize them. And markers, period, and dash. Let's see if it'll run. It says, nah, if you got a problem with what you did. Okay. Oh, those are the labels that they wanted in there. Okay. Now what? Let's go jump and look at the solution, see what they wanted from us. Here's how it is. They're not always as clear. So the plot lambda S set the X label, set the Y label. So that's all stuff that we've done. It's just how it was worded got confusing to me. And that's given all the terminology they've got above. Trying to figure out what it is that they want. So we go to our next task. And on this one, create two variables that contain the minimum values of, okay. So we want SHA. IDX equals min X and then they say find the wavelength of the hydrogen alpha line by using IDX to index lambda and store in a result. Love the way they're wording it. So we've done this part. It was S, not X. And then there we go. We check that one. We're good. Get to the next one. Add a point to the existing axes by plotting X is this, Y is this, as a red square, and the marker size. Okay. So, plot. HA, comma, next one, comma, quotes, RS, comma, marker size equals 8. Let's see if they like it. Not add a point to the existing axes. Did they want us to use hold on? They did. There we go. Do the next task. Calculate the redshift factor Z and the speed in kilometers per second at the start of moving Earth. Assign the redshift variable named Z to speed variable named Z, speed. Okay. Any of these that you don't have, I'm just going to go ahead and complete these, and we're going to jump on to the next one, because this is having us do things we know how to do. It's just how it's being presented in this context. Some of it's cumbersome. So with that said, all right, we're going to go ahead and we're going to move to the next section. And in this section, and you can back up and pause to address any code that you had in there. So in this section, got 6 tasks, and they're using some of the same comparing stellar spectra for what we've got to do. They want us to do it with a for loop. Okay, we're saying we could do it as a for loop. Modify line 2 of the script, right here, to calculate the speed of all the stars by deleting this. Will it let us do it with the parentheses being empty? Absolutely. Okay, because it's a function, we're just not being explicit about what we want it to do. So we come to the next one. And on this one, we're going to create a for loop with a loop index named v. And the loop index should progress through all columns of spectra from 1 to 7. We're going to extract the vth column of spectra to a variable named s. Okay, so I've got a couple of things. I'm going to have 4. I'm going to tab. You're going to tab. 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 End. All right. So on this one, s equals. So I'm realizing I'm working in task 1, but I'm on task 2. Task 2 for v v's 1 to 7 s equals spectra for v, and end it. Jump to the next one. Add an if statement to it. If speed's less than 0, create a plot. Okay, so we're just going to modify what's in 2-4 already. So we're going to just add to this, come down, and now we're going to put the conditional within it. If speed of v is less than or equal to 0, plot lambda s, 2 dashes, end it. Put hold on. We still got one more task in this cell, or in this section. So we're going to put an else in here, and oh, come on, else, and then there's our new plot, and then after this, hold off. Let's go ahead and submit it. We're good. And we'll go to task 5, add a legend to it. Which is star names. Let's see if it likes that. Good. And the last one, create a variable, move away. Equals star names, or speed is greater than 0. Okay. So we're just at this point speed greater than 0. Oh, less than. I want greater than. Let's see if it liked it. And it did. Let's move on. And it says, hey, here's what we did, things we covered. Congratulations, you got through it. Now, what I want you to do at this point is click Next, complete this. Okay? You got to do this first. Then click Previous. Now that you've completed that, when you come in here and click My Courses, it'll see that you've completed it and your certificate's there. Okay. If I go look, here we go. There's my MATLAB on-ramp. Share certificate in progress. You click it, download your PDF, and then upload that into Canvas. All right. Okay, that got us through the second video, and see you in the next class session.